Again, our presentation today is on the LED revolution. Our speaker is Mark Lamb. Mark is the Vice President of Engineering for Acuity Brands Lighting. He spent 23 years leading the research, development, and commercialization of LED luminaires and advanced lighting controls. He holds a dozen patents and has presented at nearly 28 industry conferences. And he's done a ton of fun. I'm sure he can tell you more about it. He earned his bachelor's in aeronautical engineering and a master's in mechanical design from Queen's University in Belfast. So please join me in giving Mark a warm welcome.
Thank you all. Everybody in the back hear me okay? Yeah. Great. Okay, going to go run through this. I am not afraid of questions. So if you have a question, you know, some of us are getting a little long in the tooth and may not remember the question by the end. So ask it immediately. At worst, I'll say I'll come to it a little bit later. So we'll go through this and we should have time at the end for questions as well. So first, there's a lot of people have been asking, so who exactly is Acuity? And why should you listen to us? You know, what do we know about things? Well, Acuity is, believe it or not, the largest lighting company in North America. You don't hear about us as Acuity because that is not how we go to market. Predominantly, we're made up of two different business units. One is the lighting side, and the other side is our Acuity Intelligent Spaces, and I'll come to that and how the two sides work together in some regards later on. We are number one in commercial lighting, number one in commercial lighting controls, indoor positioning, industrial lighting, life safety, your exit signs, etc., and in outdoor. We play in most of the other spaces, but we're not necessarily number one. You don't see residential up there, which is again why many of you haven't really heard of us. And these are the brands that we have. And a lot of these are the brands that you have heard of. Some of the bigger ones are Holophane, Lithonia Lighting, Gotham, Aculux, not so much. If you have stuff in the lighting control space, Enlight has more square footage under lighting control than any other control system in North America today. On the Acuity Intelligent Spaces side, Atrius is there. Distech competes with the likes of Johnson Controls in terms of controlling buildings. And then one of our latest acquisitions, QSC, the guys that are doing audio visual for large conference rooms, theaters, large conferences, and getting into the entertainment space as well. So that's who we are. The war is over. So for a long time, there was a question, was LED going to win? Would it really come to the fore? Let's be clear. If you have somebody or you know somebody who's still clinging with their cold, dead hands onto a fluorescent tube or a HID lamp, they won't be doing it for much longer. You could do that as well, but careful not to break the lamp because we don't want mercury spilling out. And that is the opportune thing that will really kill them when the time comes, is the fact that they do contain mercury, and more than likely legislation will come in which will ban them before people will probably stop using them. Yeah, LED has won, let there be no doubt. Fluorescent lights? Edison, when you're talking A-lamps, the little twisty ones, they are still in place today, still available today. Unlikely legislation will come after them, but in reality, it is a shrinking supply chain. The bulk of the plants that were in North America today are all gone, and most of them are now Superfund sites for different reasons, because they made something else and back to the mercury thing.
Answer the question. Why would you buy 700-hour light versus a 15,000-hour lamp?
Because my wife wanted them.
That's a very good reason that we're not going to argue it. Whoa, that went way too fast. Okay, so why did LED win? First, efficiency versus traditional, which I'll come to. The life expectancy, which you just touched on. Color consistency, flexibility, and then security. And I could keep going down the list, but in the interest of time, I won't talk to each of them. So, white light efficacy. So when we're talking about LEDs, there are lots of colored LEDs out there today, but predominantly we're talking about white light. And the DOE has been pushing this for many, many years. And I've been involved in a lot of their efforts in terms of tracking where things are going. In 2014, we were at about 150 LPW or 131 if we were talking warm white per LED. Now, not at the luminaire level. Traditional sources, for high pressure sodium, you're looking at a maximum of about that 150 lumens per watt. Metal halide, and I should use this, metal halide, about 100. Fluorescent, about 100. But when you took system efficacies into effect, they were all below 100 apart from high pressure sodium, which was doing a lot better. As we started getting into 2016, things were moving so fast that all of the outdoor market could be converted based purely on LPW. You know, that was the first one to really start switching. Together with life expectancy, the ability to convince a customer, look, you're going to save all this energy, and now you're not going to have to go up that pole and replace the lamp every few thousand hours, made a huge difference and bringing the total cost of ownership to the customer and making them change. The early adopters, so a lot of our large enterprise accounts, etc., the Targets, the Walmarts, the TJ Maxx of the world, where they're looking at millions of dollars in savings from energy savings alone, they were all converting around this period. Today, the goal is 255, and we're at about 240, 237 between warm and cool. It's going to take quite a few years to get to that 250. That's the limit from a physics perspective. But the reality is, when you're into the 200s, you have far outstripped any of the traditional sources at this point. So nobody is really looking at that anymore. And in reality, you're not going to be waiting for an extra couple of LPW. It's not worth the effort. Now, the lifetimes for LEDs are generally expressed in an L number, lumen depreciation, okay? Or what was the original percentage of the lumen output. So you will hear us in an outdoor environment talk about L70. So the end of life is when it drops below L70. Now the reality is the difference between L71 and L70 is imperceptible to the human eye. So most people are not really going to notice when the end of life is. Of course, with traditional sources, you could tell the end of life. A high pressure sodium would start blinking on and off. A fluorescent did this thing, what do they call it? Dark. So you could tell when those sources had died. But LED, that's what they talk about for end of life. In reality, it's still chugging along. It is, for those that remember, the mercury vapor of today. Indoor applications, you will see the claims generally being about L90. So in an indoor application, your customer is going to want the light levels to remain at about 90% of what they were initially. They're only going to account for about 10% depreciation. And in reality, as you know, firms such as LAI do layouts for you and for your firm, because we just design the lights, and then we have agents who go and sell them and assist customers with doing layouts and understanding how many foot candles you're going to have in this particular space. they're going to design the space for the end of life. So they're going to design it such that dirt depreciation and lamp depreciation are all taken into account. So you're looking for that 30-foot candles, and they're going to say, okay, I'm going to design it so you have 30-foot candles, not today, but in 10 years. So high-pressure sodium, it only lasted about 40,000 hours if you were lucky. Metal halide, only half of that. And then fluorescent, 10 to 30,000. Now note, I'm talking lamps. The ballasts, different story. They would last longer, but if you talk to large retailers, those that have some history, they will talk to you about relamping. And they would always relamp on a schedule. And then the schedule will be, we're going to relamp, and then we're going to relamp and reballast. So they would, every 3 to 4 years, do both the lamps and the ballasts. Because they knew, look, they're all going to start failing. And they're going to start failing soon. And they can't afford to have half the store dark. So they have to stay ahead of it. Now, it's kind of a bit weak here on this screen, but the other thing that you will see in the market, and a lot of us experienced it, we had some conversations about it earlier, lamps. The A lamps that you see with LEDs that are out there. Now, I've gone and scribbled over the logos to protect the innocent, but they are talking about double life, 22 years. And if you're the customer, you're going to grab that off the shelf and go, heck, I'm not even going to be in the house that long. That's perfect. Except on the back, there's this little caveat, because you can't see it, but there's a tiny star up there. And this asterisk is here. That's based on 3 hours per day usage. So that's what they're expecting you to use it for. Now, for residential, for a lot of us, that's true. They're also hoping none of you actually come back to claim it. As I explained to some others, my father-in-law is a wise man, and he will take that box, and he'll take the receipt, and he files the box and the receipt in his basement, and when the time comes that the lamp does fail, and it is before that 22 years, he goes back, swaps them out, Home Depot takes care of them, no questions asked. I would strongly encourage that for everybody, even on a commercial space, if you're going to buy those lamps. Color consistency. So we've all seen it. We've all looked at spaces where somebody swapped out a lamp and you see a nice troffer and it's got 3 lamps in it and all 3 are a different color temperature because the person who swapped them out just knew I needed a T8 and they don't know what CCT means. And if you don't know, don't worry, I'm going to explain what it means in a moment. They don't know CRI, they don't know anything. They just knew I needed a 32-watt fluorescent T8, and I got it, and I fixed the problem because the lights are back on and everybody's happy. The color consistency is pretty bad, even from manufacturer to manufacturer. So again, back to those enterprise accounts who knew that they were lighting and they wanted to be in the same space. They had, some still have, specifications that all of the lamps for a store had to be produced in the same batch, from the same factory, and that was the only way they were going to accept them. They would not accept multiple batches from the same factory, and certainly not from multiple different factories from that fluorescent lamp manufacturer, because they knew they couldn't keep the color consistency. That's another reason they would then swap out en masse and relamp the entire store, because they wanted to keep that color consistency. Now, the other thing to note is that color would change over time. The only good thing with fluorescent was they all changed in the same direction. So you couldn't tell that they had really differed a huge amount. Now, CFL was even worse. And by the way, I'm not throwing anybody under the bus except Acuity. This is our old office when we had fluorescents. And we got up on top of the table because we thought our facility guy was an idiot. They're both 3500 Kelvin lamps. So we got the right lamp. But because it was different batch, different manufacturer, it was sufficiently different in color. And CFLs were even worse. They were very different in terms of color. They all shifted in different directions, and the flicker was pretty bad with them as well. And then metal halide, don't talk to me. You know, that was initially would start out as everything looks really white, but as time went on, you could have a rainbow of colors if there was any sort of indication. If you're lighting black asphalt, nobody's going to notice. But if you, in this case, have a nice, pristine, mostly white and or light gray parking garage, people are going to start to see the colors and it's going to look pretty horrendous.
So for somebody who's not familiar with the electrical engineering and all that stuff, more of an adjustment, why this change? You have
Why is the color changing? So within each of these, you've got various phosphors. They are degrading over time, and the various chemicals within them are just degrading over time and shifting the color of the actual lamp. It's something we understand with LEDs. We just understand it a lot better, and we work to mitigate that as well. There is color change with LEDs. It's just significantly less than any of these technologies. And if we are smart about it, we can control it in a much better way.
How quickly would it change compared to, because you said the fluorescent can change like quickly from the color temperature. How many years would it take for
So,
an LED?
so if, yeah, no problem. So the question is, how quickly does LED change? So I can take very good components and make an incredibly bad luminaire. So let me put it like that. So it's how well you treat it, as with any technology. You know, I can kill an LED just by dropping it in water. You know, not advisable. But that's the same with all the other lamps as well. The reality is for LEDs that for a color shift to be as significant as metal halide, you're probably looking at somewhere in the region of 1 to 2 decades. Now, the other thing to note, however, is as that shift occurs, everything will shift in the same direction. So back to what we talked about where the enterprise accounts understood that fluorescent would change and shift together over 4 years. We understand that LED will shift over 10, 15, 20 years, but they'll all shift together. If you're treating them the same in terms of temperature, current, etc., they'll all shift together so nobody's going to notice. That answer your question? No problem. And LED can be very consistent when understood. I've sort of alluded to that. This is a large retailer, just a photograph from their checkout area, and you can see the sea of lights. If you're in the lighting industry, you have this, we all have this very bad habit when we walk into a building, we do this, and we look to see what's in place. So this is a normal view for us. We look, and we will look to that entire store and breathe a little sigh of relief when we see, yes, everything's on. You know, the checkerboard pattern is all consistent. There is nothing that is off or dim or anything of that nature. Now, HPS, in fairness to it, it was very consistent. It's just consistently yellow. And that's all well and good so long as you don't have a brown or blue or green or red car and there's 6 other cars the same color parked in the parking lot because you can't tell which is which. High pressure sodium. So HPS is high pressure sodium. You will hear us collectively refer to the large arc lamps as HID, high intensity discharge. You've got metal halide, high pressure sodium, low pressure sodium, and a couple of others. Low pressure sodium is very amber, has a very narrow bandwidth in terms of color, and was used, specified a lot for observatories and anything in the area of an observatory because they could filter out that narrow bandwidth of light and know, right, I've got everything else and I've filtered that out. So they didn't have to worry about the lights in the surrounding area. And then flexibility. So LEDs have truly provided flexibility for designers and everybody in what they can think of to be able to do with light. That flexibility wasn't there before. Today, the light that we're getting out of these 8-inch CFL cans above us can easily be produced in a 2-inch aperture, which makes the ceiling less busy. And one has to be careful. One can make it so that there's too much light coming out and it can be an uncomfortable glare, but a solid designer will, recess that up into the space so it's not, glare in one's eyes. Security can be enhanced. So this is something not a lot of people think about. As you look, and both of these images are on the same computer screen. This is the front and the back of a building at the same time, and one parking lot had been converted to LED and the other was still HID, metal halide. You can guess which one was which. The reality is our eyes and security cameras are not the same. Security cameras can see a much broader range of wavelength than we can. So they're able to take all of the wasted light that our eyes can see and still convert it into an image. So people get to see a much better lighting experience. Now, the LED in this particular case is consuming 65% less energy than the HID. And yet you can see the improvement. So this customer did not have to swap out their cameras or anything to improve their security. They simply had to swap out their lights in the space. So let's talk about some of the basics, because I've talked to some of them. Now I know there's some people in the room, this is going to bore them to tears, so I apologize in advance. So what are LEDs? Color versus white, CCT, CRI, and then TM30 that you're going to start hearing in the industry. So there are, and I've got some samples I'm going to hand around just so people can understand the scale of these, because you see it on a screen and you can't really have a sense of what you're dealing with. So we've got high power on this board. They tend to be domed. They tend to be run at least an amp. You've got medium power. These are running at a couple of hundred milliamps. You've got COBs. These can be running quite hot. And then you've got CSPs, chip scale packages, which tend to get clustered and are replacing COBs in many applications. If you're looking at lumens per dollar, this is where you're at. This is the medium powers are what are in the bulk of indoor lighting today and a lot of the commodity goods that are out there. CSPs are a little more specific and tend to be utilized if you're trying to do color mixing and or get a lot of light into a small space. In terms of lighting control, if you want to control where the light is going, because the high power LEDs have the dome above it, it brings the light into a much tighter controlled beam, which we're then able to control with optics and put it into a pattern that we want for outdoor lighting. So that tends to be what you see in outdoor lighting, the higher end outdoor lighting. And then COBs, they have their uses. They are less controlled, but in an outdoor space, if you're looking for dollars per lumen, you will see COBs used. Now, we talk about color versus white. A lot of us are seeing colored LEDs everywhere in our life. Everybody's seeing stuff on Amazon. It's all cheap. It's all controlled via an app. That's wonderful. And you'll hear us talk about that as RGB. Now, with your RGB LEDs, you can, in fact, mix them to get a white. Tends not to be quite the white you're looking for. you'll get it and you'll go, ugh. Better control systems, if they're going for that full color tuning, etc., will be an RGBW. They will have a white in there as well to help it, or they'll have a different anchor color to try and control that lighting a little bit better. That is out there in the industry. It's coming, but I strongly encourage you, try out the stuff at home before you go and commit to a cheap brand in your commercial application. As many of us have experienced, I know myself, you get these brands, they almost seem too good to be true, and they work great initially, and then after you've done 5 firmware updates over the air, you kind of get fed up dealing with firmware updates because they're constantly fixing something. They are constantly, in fairness to them, having to keep up with what Google Home or Alexa or Apple have done in terms of their applications, etc., and their hardware and software in the back end, so they have to update theirs. It becomes a never-ending cycle of having to keep that up. In a commercial space, our customers can't take that. That is not something they're going to tolerate, so we have to have something that's going to last for a decade or more in that application. Now, the reality is this has the potential from a physics perspective to be a higher LPW. But there is a lot of research to be done. There is a lot of research dollars being poured into it. But the bang for your buck on the simple blue LED with a yellow phosphor placed over it giving us white light is much better and is a much easier sell. So how far this will go, we'll have to see. I don't expect it to come anytime soon.
Does that have a nomenclature to the one on the left?
You'll just hear us talk about RGB, red, green, blue. Now, the other thing that you'll hear us talking about, and this is as you start to go into Home Depot or on jobs, you're worried about the color of the light. Those of us in the industry refer to it as the CCT. So that is the correlated color temperature. Correlated is, as it looks, correlated. What's it correlated to? It's correlated to the color of a bar of tungsten at that Kelvin temperature. So if I have a bar of tungsten, I don't, and I heat it up, I can't, to a very high temperature, we all have these expressions, it's red hot. Well, if it's red hot, it's at about 1800 Kelvin. If it gets white hot, I'm getting to 4,000 or 5,000 Kelvin. So that's where we're talking about that. And the odd thing is we refer to the warm temperature as this, and the cool temperature as the ones that are hotter from a Kelvin perspective, just to totally confuse everybody. We have that backwards. But people are talking about the color looks warm versus the color looks cool. But that's what that is related to. And that goes through our CIE diagram, and this is the various whites that you will get. But also note, I can have white at 3000 Kelvin, but I can be a little bit above, and this is called the black body curve. So this is the color that that black body will be at as it heats up. But I can be a little bit above and I'm still at 3000 Kelvin. Or I can be a little bit below and I'll still be at 3000 Kelvin. If I'm a little bit below, it'll have a pink tinge. If I'm a little bit above, it's hard to see on this, it'll have a green tinge. So this is where we're controlling exactly how we're buying those LEDs, so we control how that color will be handled.
But that's not something we can change at the consumer level.
It's a fair question. It isn't, except ensure that you buy what you want in terms of a color temperature.
Okay, you buy 3,000.
You say 3,000 Kelvin. In an outdoor application, the reality is, nobody's going to start color comparing between a pole lighting black asphalt over here and one that's 200 feet away, because your eyes will still be full of green dots by the time you get to the next one over here. There, we talk about 7-step macadam ellipse is sufficient control. As you get into an indoor environment, 3-step and below is what you're going to be requiring. That's deeper technical that I don't have on the slides, but we control it via macadam ellipse.
But it's the product that we purchase, so if we're doing our house.
You would want to ensure that you're getting the right CCT, and, you know, kind of like we talked to earlier, don't mix up lamps or luminaires. Stick with the same lamp or the same fixture from the same company in a room, just to be sure. Now, the other thing is, yes, Bill.
You might say also, when you get the color temperature, as you go lower, 2200, it becomes yellow. So it doesn't put out a lot of light. As it goes to 3000, it becomes a little lighter, so you see it better. In my house, I use 35K, because I like a little bit brighter, but I'm not real white. If you remember the original LED outdoor Christmas lights that were blue, they were 6,000.
Yeah.
So that's going to give you the idea.
The broad range.
You want to be, but it's your visual, not a number. So you have to look at it to decide what you want.
The issue is if I go to Home Depot today and I buy a light.
Yeah.
I buy one of,
You just buy a down light.
buy something, it's an LED light, goes in my can.
Mm-hmm.
Well, that one over there fails and I gotta go buy another one.
Yeah. You need to remember what you bought.
This one was a GE and they don't have those
Go to
anymore.
Costco
Yeah.
and have a little slide switch on all the lamps. Bring it all the way to 6.
I'll show you something in a little while. So, color rendering index. So, you've chosen the color of the light you want, but how well does it make colors pop in a space? So, fluorescents had this issue early on, and that's why they came out with this CRI numbers for them. Now, they focused on the first 8. They didn't actually focus on R9, which is red. And that becomes very important for a lot of customers. But when you get a CRI number, it's going to be the average, of these first 8. Now, we can take some liberty with the phosphors used in the LEDs and choose one that can make something pop just that little bit better. So we're doing that today for some of our retail customers. Now, they have a concern, as do we, that as they go and choose this, that they could have some buyer's remorse as the person takes it out into the real sunlight, and it may not be the color they were expecting, because this is like, putting an even better light than you might be able to get on a shiny day. Now, there is the weakness we talked about with CRI, so they have come out with TM30. You'll start to see that creeping into specifications where people are looking at the RF and the RG, the fidelity and the gamut, and they're looking at how well it renders in the space. Hard to see on this screen, but this is a much broader range of colors, and they're going to measure it up to 100 and start looking at how well it performs in that regards. So what's next? The stuff that you guys and gals really care about. So we talked about it already. We're not going to see.
Before going back to that.
Yes.
So what is it that you can do to get the CRI where you want it? Is it the
So-
LED physics or is it
So for us, it's LED physics. We will choose the LED that meets the specification. As you order a product from us or from anybody in reality, there will be a spec sheet, and you will see different CRI values. Generally, it's 70, 80, 90. If you are ordering a 90, you're probably either doing the Ferrari dealership or you're doing something inside. If it's that, you're probably going to want to ask the supplier, what's the R9 on that? Because you will probably want the reds to do well. 70 tends to be used for outdoors, 80 for more commercial applications, 90 for residential and high-end stores that are really wanting their product to pop.
What's the price difference between 70, 80?
Between the 70 and the 80, the price difference should be negligible, if at all. The 90, there might be a little bit of a price bump, simply because they are more rarely ordered, but we're talking single-digit percentages. It's not going to make a huge deal. Where you are going to suffer, however, is if you want that 90, you're probably looking at a 10 to 15% efficacy hit. So now your customer is going to pay it for it in terms of efficiency through the total cost of ownership of that product. But the Ferrari guys really don't care. So what's next? Like I said, LPW improvement, that's not really coming. Better lighting quality is coming. So we have products going into the market today where we can, for a little bit more, offer you a 90 CRI that performs at the same efficacy as 80 CRI. So those products are starting to come into the market. You'll also start to see LEDs that have a broader spectrum of light. They're more fulsome, will render more colors better in a space. But as you get to that, you're going to pay for it in terms of efficacy as well. But there's a lot of research being done in that regards. The next thing, circadian lighting, I'll come to, even more design flexibility. The commoditization I'll talk to. There's some positives and negatives. Controls, and then controls integration into building technology. So, circadian. Who's heard the term circadian? Okay. For many of us, it started to come into the public perception and knowledge and realization when our phones started to change color on us at night, because they wanted to at least give us the perception that they cared about our health. Our bodies work on a circadian rhythm.
It also came into nursing homes and hospitals.
And I'll come to that. So it came into the public consciousness there, but the reality is, for all of us, we all have a circadian rhythm. When it gets out of whack, we call it jet lag. But the reality is we all have a circadian rhythm, and it is driven for millennia off us and our relationship with the sun. We are still learning about it today. In the last few years, we just learned about IPGRCs, intrinsically photosensitive retinal ganglion cells, which are in the bottom of your eyes, and they have nothing to do with vision, but they are detecting the light coming from above, so that's why they're at the bottom of your eyes, and they are in turn controlling your glands and a lot to do with your circadian rhythm. So we care about that. We have products offered in this space to help people, but generally speaking, when people specify it and then they get to see the sticker price, what happens? They VE the job. So they take it away and they go, it was a nice idea, but I'm not going to be able to get the customer to buy that. So for us, generally speaking, this is between our cortisol level and our melatonin. That's what is controlling it. And then the light in turn is affecting those levels. So ideally, in the daytime, you want blue light that is going to wake you up and make you perky and do even better than coffee. And then as the evening comes around, you want to have warm light, just like the setting sun, or reduced light, so that your melatonin can build up and allow you to fall asleep easier. This is why you shouldn't, we all do, be looking at your phones before you go to sleep. You shouldn't probably be looking at the TV before you try and go to sleep. If you want to sleep well at night, turn it all off, read a book before bed, under a nice, dim, warm light. Just enough to read, not enough to perk you up. And another interesting point back to the healthcare situation, if you, not that any of us are of that age, are a person who gets up in the middle of the night to use the bathroom a lot, a red light or a deep amber is what you should have as your night light in the space. It's enough light for you to see where you're going. They use it in hospitals and senior care facilities now because it causes less interruption to your sleep cycle and to your circadian rhythm and allows you to get back to sleep much quicker.
Pilots and military have been using red light for night vision.
Yeah, they're using that more on the infrared side as well, though, and then kind of we can't see that as we walk through the space. Now, so let's flip this around. You want a lot of light when it's nighttime. We don't want to go and put nice warm light on the roadways, because the last thing we need is you starting to feel really rested as you drive home and decide to fall asleep at the wheel. Not a very good scenario. In an office space, you do want people to be perky and working away. You want them to come in. Putting a nice relaxed light in the space might look nice, but you may not have the most productive employees. You might have people nodding off at their desk through no fault of their own other than you made them very relaxed. There is a lot of talk about blue light and that it's bad for you, etc. And that is true to an extent. The big shining ball that you see every day up in the sky puts out a tremendous amount of blue light, and if that was deadly to all humans, we wouldn't be around on the earth. The reality is, blue light, regardless if it comes from LEDs or any other light source, is something that you should not be experiencing as you are trying to go to sleep. You're interrupting your sleep cycle, etc. So, I would strongly recommend everybody get nice blackout curtains for their bedrooms. Even on a moonlit night, there's going to be a lot of light coming in and that will interrupt your sleep. Getting into a nice dark space is the best thing you can do and not to be holding the phone straight to your face. So, as we see the trends, where circadian will take off and is taking off now, because it hasn't really crept into the major markets, healthcare. Because that's where they do want people to get well soon. If you have people who are on a good circadian rhythm, and we've all seen it in hospitals, you go in, it's like going to the movies. You don't know what time of day or night it is on the outside. They tend to treat it like it's the same time all the time. In reality, they need to have circadian rhythm in the space, because people who are better adapted and fully adapted will heal better and faster, and that's what they want. They want those patients turning. There are studies out there demonstrating that senior living spaces with circadian lighting and better lighting in the space have less accidents, have less falls, and have less disturbed residents at night who are getting up and walking around because they can't sleep. The trend for architainment and higher end luminaires will continue. This is Penn Station today, and it is a beautiful experience. Not cheap, but a beautiful experience for anybody walking underneath it and literally watching the clouds roll by and giving some of the impression that they're in an outdoor space when they're actually indoors. Now, commoditization. The pros of commoditization in this space are There are a lot more options in fewer SKUs and better pricing. So LEDs are getting more and more competitive today with the older technologies. The reality is at this point, in terms of lumens out, the fixtures that you have today are by and large significantly less than their fluorescent and HID forebears. This is, where agents and ourselves struggle. We are selling greater volume for less dollars. So for the entire industry, the commoditization is a difficulty that we have to work against. And if we want growth, we have to sell more volume. In terms of the options in fewer SKUs, so in the good old days, your distributors would hold a product on the shelf, and then the customer got to decide what lamp they were going to put inside. So if they wanted 3500 Kelvin, they went and bought a 3500 Kelvin fluorescent. As we came out with LED, we offered them a luminaire with inbuilt LEDs, and we offered 3000, 3500, 4000, 5000 Kelvin. So now the distributor went from having one product on the shelf to 4 products on the shelf. And then we want that same product in 10,000 lumens and 15,000 lumens and 20,000 lumens. So now he's gone from one product on the shelf that you could swap out for brighter lamps if you needed to 12 products on the shelf. They don't have that much space on their shelves. So we've started offering products that have switches inside and will allow you to start switching the color temperature of the product. This is where I'm not recommending this for your house, Richard, but it'd be good in your garage, but also as you are trying to explain to she who must be obeyed what you need for the house, you buy a product that you can switch and she gets to make the choice. And the great thing is she's allowed to change her mind and can change it later as well. Now, as we go to this, you also then can make it brighter. So again, the customer can decide, and you were saying earlier, Richard, somebody had a job and the product was, you put it in and oh my gosh, it was so bright. We, of course, have customers complaining about the same thing. Benny will come along and then try and sell them a control system to dim it, or they will buy this and they've got a switch and they can decide what light level they actually want. And this still can be dimmed as well. And I'm showing you a high bay, but this technology is in strips. It's in outdoor lighting. It is in troffers. How much is this? This is retailing for anywhere from, depending on the lumen package, probably anywhere from 150 to 250.
End user, low wattage 150, high wattage 200. But it takes all the, like I said, it can do so many things.
Yeah. And for a contractor, they will buy that, and they know they'll get the job, and the customer will be happy. They won't have to take it back because the customer says, oh, that's too bright, or I don't like that color, that's too cool or too warm or whatever it may be. They get to show the customer, switch it up to whatever the customer wants, and you end up with a happy customer and a happy contractor who doesn't have to come back to the job.
Do those have Bluetooth or anything capable where you can do it from the ground floor?
There are luminaires that can do that, and we have those luminaires. Generally speaking, what we've seen is the likes of Amazon will buy that product. What we have seen is the customer isn't willing to pay for the added cost of the Bluetooth option, because what they will do is they will get the contractor up on a ladder or a lift for the first one. They'll get the first one right, and then they'll switch everything else on the ground and install after that. So they only have to go the first few to say, do you like this? Don't you like this? Okay, good. And away they go. Oh, sorry, pardon me. Then we get back to the cons. There is quality erosion as we get to commoditization. As things get lower and lower in cost, people are cutting corners. So it is a case of buyer beware. So there are a lot of less reputable players out in the market. I would strongly recommend you start checking who you're buying it from, how long have they been around, and just Google their reputation and see how many stars they're getting, etc. Because the reality is, we have seen, in today's market, a lot of suppliers and competitors of ours going by the wayside. Acuity Brands has been around for in some cases, over 130 years. And it is imperative that we're able to honor our warranties and have return customers, because we have the intention of being here for decades more. So we have to keep customers happy. For some people, they are out to get the sale for today, and they don't care if their 1-800 number works in 3 years. So, warm CCTs in the application, and offering people the ability to swap out that color and be able to achieve what they actually want is why we're looking at that. Now, when we talk about lighting controls, this is not what we're talking about. We know you've all seen a closet that looked like this, and somebody thought it was the best thing they'd ever done. We're trying to get away from that. We would much prefer you looked at something like this. This is what lighting controls should be, and modern conference rooms are all leaning towards this. The lighting controls, they are networked. More and more are moving from wired to wireless, particularly in the retrofit space, as we start to move things away from having to rip out walls to put wires and control wires down them. Wireless is the way things are moving. And because it is harder and harder to get good electricians and good contractors, we encourage the sensors to be integrated into the luminaire. It is one less thing for them to screw up. So they just install the luminaire, they go and connect the power, and they're good to go. And then somebody comes in and sets it all up on an app, and you just charge them a small fee for the privilege. Lighting controls, you can set up things with zones, and they can have sensors that are very responsive. That's what you want as you get into a space, so that you see a parking garage, and as somebody walks in, it starts to fade up. The customers who are walking into that parking garage, we want to be able to control this in a manner so you notice the way that faded up. That did not step up immediately. There is the startle effect that customers don't want to experience. You don't want to walk into a space and go from 0 to bam. That literally will give customers pause. If you're walking into a dim space and it gets brighter as you enter, that's comforting. That's a much more pleasant experience for anybody walking into that space. And being able to see as you walk into the space is a better experience as well. So we encourage people to keep it at a low dim level and then go up from there. We've all gone into a room and waited for the lights to come on or tried to find the switch because you're not walking into a dark space. You don't feel comfortable doing it. In the educational space, multiple zones, preset scenes, basically taking the controls and making it a more usable space for the application. So as you have people working, you want it such that the lights in the back of the room aren't lit, the teacher is or aren't as bright, the teacher is well lit. Or if they're doing a presentation, dim the lights that are by the projector so that the light up above, we don't have this situation. You've got the projector being in a dark space. The next step is for the controls to integrate into building technology. This is truly where things are going. Today, most of the control systems in a building operate independently. HVAC guys control the HVAC, the lighting guys control the lighting, the power guys control the power. It's all separated. But if we're going to optimize these buildings of tomorrow, all of that technology will have to operate interdependently. They're all going to need to work together. And lighting is becoming a key asset to that and also helps with wayfinding. Why is it becoming a key asset? Well, as you start to look at all of this coming together, you need sensors to know where people are. You need those sensors to be powered. What better place than put them in the light? We tend to have it on a nice square grid. You know where they all are. They get to sense the people in the space. Technology is there now where you can detect how many people are in the space. Therefore, you can decide what to do with the HVAC systems that are coming along. As you look to wayfinding, and if you open your app and look at the Delta app, American Airlines, United, and a few others, and you decide to figure out where's my gate relative to me, it'll pull up a map. That map in the bottom corner has an Atrius logo. That's us. We're the ones providing the wayfinding for everybody to get from their gates between buildings. It's the same technology that's in the Target store as you walk in and try and find your way around. So all of these systems are starting to come together, and the reality is, as we look to this, what we can expect is, in the past, we just had information. We just had a basic map. As things have improved, we've had analytics. We've looked at what has been possible, what's happened. And now we're getting predictive. AI is moving into the space. The reality is, a facilities guy isn't going to be able, he's barely able to keep up with the various controls he has for HVAC, for the lighting controls, for the power systems, the plumbing, the water, everything else for the building. Optimizing them all between each other is something that he's never going to be able to do. AI will. But in order for AI to be able to do it, all of the systems have to be connected. They all have to work together and be able to provide a full data set for that building and allow the owner to optimize it and eventually save money. So all of this is coming together, and the end product, in reality, is going to be sustainability. That is what we are driving towards as a company and as an industry, to provide more sustainable lighting and building controls for all of our customers. And with that, thank you. But 4 minutes to spare. You all asked a lot of good questions. Any other questions? Yes?
You see the numbers of 22 years, 30,000, and I believe that's possibly believable for the LEDs themselves, but the drivers seem to be the weak.
Fair. And they seem to be the weak link because they are the weak link. So the reality is, we have got customers today with drivers that have been operating for 10 to 12 years. And we have pulled product from the field and looked at it, and our driver teams have said, yes, this is, as we predicted, in 10 to 12 years, getting towards its end of life. Now, their definition of end of life and your definition of end of life aren't the same. Their definition of end of life is, it is going outside their specifications because the electrolytic cap is drying up and not providing exactly what it was supposed to. It will eventually get to what we would call end of life, otherwise known as dark. But for them, it's just outside the specifications. But again, that's not ideal for a customer. And for a large customer, a large project, you can't have the maintenance guy repairing and replacing drivers one-on-one, because it will eventually get ahead of him and you'll have 25% of your space dark and he won't be able to do it. So you have to pre-plan.
You had mentioned LED technology in healthcare.
Yes.
This was a care facility as opposed to an operating room.
Correct.
requirement. How about other industries such as indoor agriculture?
So, fair. Plants the horticulture space is something that took off significantly in about the last decade, driven predominantly by the cannabis industry. But there is still a healthy industry for that non-medicinal purpose. A lot of herbs, anything that is high value and needs to get fresh to the grocery shelf and therefore to the customer. There are several large facilities in the Atlanta metro area. More than likely, if you are buying herbs of any shape or description from a large grocery store, it was probably grown under LED lighting and harvested within 50 to 100 miles of that store.
How about entertainment lighting?
Entertainment lighting has probably 5 to 10 years ago fully converted to LED. Their old technologies simply couldn't do what they can do today. It has moved wholesale to it. Back to the horticulture thing for just a second. The lighting we use in a horticulture space is not what any of us are comfortable with as humans. It tends to be focused on, they will promote growth by putting a lot of red into the space, and they will supplement it in ways that you can't normally get. Depending on the plant, some plants will tolerate 24 hours of sunlight and grow, or of light, and grow a lot faster. Others have to have an off cycle. So if you try and grow them for 24 hours, they will die. So depending on the plant and what they're doing with it, they will treat it in different ways with lighting. But it's a very interesting area. I grew up on a dairy farm. I'm very interested what's going to happen in the animal space. Happy cows make good milk. How do we make cows happier with lighting?
How about any other industry applications?
So within the other application that we're seeing LED lighting coming into, we had hoped it would take off more during COVID, but that is UV lighting, or GUV, germicidal UV lighting. So you're starting to see some work being done in upper air and or water treatment and or in air duct UV lighting. We, as humans, can't have the bulk of UV lighting on our skin or on our eyes. It will harm us. There were people selling stuff on Amazon during COVID. For those of us that knew what was going on, it scared the living daylights out of us because we were afraid people would literally blind themselves with this stuff. So you have to be careful with it. But there is lighting in the world today which utilized in some cases in operating rooms, where when the operating theater is no longer in use and the occupancy sensors in the space detect no humans, it will turn on UV lighting, which will irradiate the place, and it kills darn near everything, including COVID. So anything that they missed with the wipe downs and all the rest will be taken care of.
Power quality concerns. I have heard that, I have an old house built in 1959, and the way it's wired is mind-boggling.
Yes.
There's voltage on neutrals in some cases because of the way they cross circuits when they're wired in. Does that shorten the life of these LED lamps? I know I have certain rooms,
Yeah.
they don't seem to last very long.
Yeah, yes and no. It is shortening the life of the driver that is powering the LEDs. In some cases, if it is really bad, the driver will let that poor power quality through and it will fry the LED. LEDs themselves are fairly delicate. But as we deal with poor power quality, it is very much a concern for us. We are constantly looking for ways to design more robust drivers. We put surge devices in front of any of the ones going into roadway applications. You know, we're basically putting them on top of a 30-foot lightning rod. So we have to put protection in those spaces. Some of the hardest applications that we are trying to convert now, because the customer frankly can't get the large HID lamps anymore, are these heavy industrial plants. And the power quality is so bad that it is frying every LED luminaire that goes into the space. The old metal and copper wound ballasts that they had, they, cleaned up a lot of stuff before it reached the lamp, which in turn was more robust. So that's still a concern for us. Generally speaking, yes, in your application, we're probably going to encourage you to rewire the house. You don't want to hear that, but that's what we're going to tell you.
I recently had to design a job where you got to take like retrofit a light and stuff. How? I guess because I've seen them where you do the linears and then it's like
Yep.
you got to bypass the actual fluorescent ballasts.
Yes. So there's the retrofit market is a market that we take a lot of value from, and we have options where in a trofo or in a downlight like this, we can give you an option where you can take the guts out of that luminaire and put brand new LED guts in. And it will look like a brand new luminaire. It'll change the aesthetic, and in this case, change the aesthetic as well, without you having to bring necessarily an electrician in. Some of you may have done that with your own home, where you've actually used the old can, and the socket is there, and you can screw in an LED, pops up, looks completely different, and you probably have the option for color changing as well. There are, however, LED linear tubes that look like fluorescent. There are 3 different types. There's the type that you simply put it right in where the fluorescent was and it runs off the ballast. You have the type that you have to replace the ballast and go and put a driver in and then put the LED tube in. And then you have the type where you cut out the ballast and all the rest and you run direct AC to that lamp. That's all well and good. What I will tell you is any of the enterprise customers who have gone that way have only done so once, because the failure rates that they were experiencing were much faster than they had hoped, because the problem you see with, again, all of the A lamps that you see and that 22,000 hours that we saw on that, and all of the lifetimes they give you, are for a lamp that isn't hanging in open air. And then we go and we put them in a nice little oven, and it heats up inside. Be it put it in a can, put it inside something else, and it just cooks itself to death, and they die. And then the real concern for those of us that aren't selling them, but part of the reason that we've avoided selling them is hoping that the person who put the first LED linear in there, which was either an A, a B, or a C, is still around to tell you, was it an A or a B or a C? Because you shouldn't want to put one into the other, because I would hate to imagine what will happen if you put something that's expecting low constant drive current to plug into something that's got full AC coming at it. You're going to have a small thing called a fire. Huh?
Right, label the fixture.
And that is what is shipped with the product, and the person is supposed to go and put, that's the only way UL has allowed it. They're supposed to put a sticker on the inside of the luminaire to explain it. Now, I'm on the committee that voted on these things. My concern was, and I expressed it and I was overruled, was that when the lamp is out, it's very hard to read the label because it's dark.
I did better than that. I cut part of the label off the box and put it on the fixture because it's a lot more prevalent, and it tells you exactly what lamp you got in there.
And I pray that you're there when the replacements need to be done in years to come.
Well,
Okay. Thank you all. Appreciate it.